This is our final last session for 2021, and it's wonderful to have you all here today for this session with members of the Ontology and Conceptual Modeling Research Group, NEMO, at the Federal University of Espírito Santo. We'll have Professor Giancarlo Chizzardi from the Free University of Bozen. And then we have Professor Andrade Almeida from the University of Federal University of Espírito Santo, and we have Christine Griffo, who's a postdoc in computer science at Free University of Bozen. Tell us about the Unified Foundational Ontology project that they have been working on. And so this is a topic that's of keen interest to folks in our group, and we're very excited about this conversation today. Before we launch into the substance, I wanted to see if anyone in the group had any news to share, or any updates, or any requests from the group. And as always, please, feel free to unmute yourself or.
Hi, Roland.
Yeah, Michael, go ahead.
Hi, it's Michael Schmitz. We're going to talk next month in January about the work that the Climate Data Policy Initiative is doing, but I wanted to take the opportunity to introduce Catherine Atkin here, who's come on as co-director, just got back from Glasgow, and we're standing up a lot of really exciting new initiatives relating to latest technologies and climate. So welcome, Catherine.
Fantastic.
We'll talk to you in January, yes.
Great to have you, Catherine, and we look forward to your presentation. And it's kind of hard to think of many other topics that are more important than than the work that you're doing on climate policy. So
thank you, Roland. Also, Tony Lai and Ruben Youngblanc are also part of our group. So excited to bring forth thoughts and insights from the work.
That's great. Fantastic. Well, wonderful. Thank you so much. And yeah, we're excited to see this will be one of the early sessions early next year. Robert saying he's looking for a rule of law ontology schema and tools for implementing law being passed now in the Illinois legislature, sponsored by the Illinois Speaker of the House. Robert, you want to elaborate a little bit, or?
Hi there. Thank you. I appreciate it. I'm very honored to be part of this group. I have experience in having worked with one of the most powerful, two things. On the technology side, I worked with Ontobroker 10 years ago. Ontobroker was funded by Paul Allen, over 50 million invested into that inference engine. So I understand ontologies and schema. I'm very, very interested in the legal ontology space because I built a platform there previously. Fast forward to today, I'm working on a bill. It's called HB for House Bill Illinois. You got to go IL. I'll type it here. IL is the Google search, and HB 4251. And we're fixing a loophole in the probate statute in Illinois. And because I'm authoring that law, in part with the speaker who filed this originally, he's probably the most powerful African-American legislator in Illinois, and he's met recently with President Biden. So there's a real opportunity to, bring awareness to the community here with real legislation that I want to show exactly how we can take legal code and articulate both the problem with the current law, which is a gap in the rule, and using a rule-based solution, allow others to be able to ideally just not only run an app off of it, but obviously visualize it, and visualize it in both text as well as ontological graphing. So I'm very, very interested in this. It's active. We've had a lot of money invested in to get here, and I'm happy to work with anybody and check out other people's tools, help them get traction in the market. We got a little venture lab working on this space. We just partnered with the Stanford Peace X group. So we're looking more forward to getting to know you a little more.
Fantastic. Well, we're looking forward to getting you more involved, and perhaps you could give a more detailed, overview of the project at one of our upcoming meetings. But in the meantime, maybe some of the folks in the group here, they may already have some synergies and ways to collaborate. So yeah, please put your contact info in the chat so folks could reach out to you directly. And Professor Schweikofer is sharing about IRIS conference, which is of course an institution in legal technology and legal informatics. And we've had a joint session in past years, and I think it'd be great to do this again next year. That'd be wonderful. And Professor Williams, joining us from Sydney, is working on an AI and innovation lab in a business school at UNSW in Australia, University of New South Wales, I guess, in Australia. And they will focus on AI governance and entrepreneurship. So that might also be many connection points around your work for this new innovation lab. And we know Professor Williams, if she takes on a new project, that usually is going places. So I think we're excited about this, and hopefully there will be connection points around this. Okay, well, great. So with that, it's just updates from our side too. At the beginning of this week, we ran a 3-day conference, Computational Antitrust. Our CodeX fellow, Thibaut Schrebnel, was really driving this and really put together, I think, a unique event. We'll publish the videos in early next year. And it was just, I think the starting point of a really interesting conversation. And again, thank you to Thibaut. I don't know if he's here today, but he really did a fantastic job with this conference. Everyone who worked with him really did a great job. So good. Well, with that, Joao, are you getting us started, or who's?
No, I'll start the presentation.
Oh, Giancarlo. Okay, Giancarlo.
Yes. Let me try to.
Over to you.
Thank you, Roland, and thanks for the invitation and the opportunity. Let me see if I can share my screen. Okay. Do you see the screen in full screen mode?
Yes.
Okay, thank you. Perfect. So this is a talk about, on one hand, the relation between ontologies in a more philosophical sense, so a system of domain-independent meta-categories and how they can be used to build ontologies in lower levels of abstraction, and in particular, one ontology in the domain of legal relations. And on the other hand, how this ontology in the domain of legal relations can be used to evaluate, redesign, and evolve conceptual modeling language in that domain. So we'll start with the relation between conceptual modeling and ontology. And then we're going to evolve. I'll talk a little bit about a particular fragment or micro theory inside this general theory of meta-categories I was talking about, which is a theory of relations. And then Christine Grifo will exemplify an instantiation of this theory of relations to model legal relations. And then João Paulo Almeida will talk about the application of this theory of legal relations to evaluate and redesign a international standard called Archimate for enterprise architectures. So conceptual modeling and ontological theories. First, on conceptual modeling. Conceptual modeling is the activity of representing the physical and social world for the purpose of communication, problem solving, domain understanding, and meaning negotiation among humans. It's a discipline that is fundamental to many areas in computer science, for example, so database design, knowledge representation, software engineering, but goes much beyond computer science. This characterization here makes clear that conceptual modeling is like an interface between reality and cognition. And every information system, actually every information artifact that is not just a piece of mathematics that has what is called a real world semantics that represents something in the world, makes an ontological commitment. It's a representation of a given worldview. And this is unavoidable. So this very mundane database here believes in the existence of people who can be living or deceased, transplants and surgeons and donors and donees, and that they relate somehow to this notion of person. So this idea that data represents a theory of the real world is a very old idea in computer science. Actually, dates back from this paper, at least to this paper by George Mealy. George Mealy is the creator of Mealy automata, which are very popular in computer science. He's also the PhD supervisor of Peter Chang, who created the entity relationship diagrams, which are also quite popular in conceptual modeling. And in this paper from 1967, Mealy explicitly defends this idea that data are fragments of a theory of the real world. And what we do with data processing is manipulating these representations. But more than that, he defends that this is an issue of ontology. And this is actually the first mention of the word ontology in computer science. And Mealy is actually referring to ontology here in two senses, in the two most common senses of the word. In the first sense, which the ontology with the lowercase o, is that, that every information system embeds a theory about the kinds of entities and their ties that are assumed to exist by that given description of reality. So this is a view of ontology that is associated with the philosopher Quine, which explicitly mentioned by Mealy in his paper, but also with perhaps the greatest living metaphysician, the philosopher Kit Fine, who defends this definition of ontology. So in this sense, if you're building an information system, or if you're building any information artifact that has real-world semantics, you are doing ontology work anyway. This is unavoidable. So this is the first takeaway message, that the opposite of ontology is not non-ontology, it's bad ontology. We're doing ontology work anyway when you're creating an artifact that is making distinctions, that is embedding a theory of the real world. So how can we do good ontology? Well, we can do good ontology. One way, one dimension of this problem of ontology quality is doing ontology with the lowercase o, so a particular theory, with the help and the support of a number of tools created over 2,400 years by ontology with the capital O. So ontology with the capital O is a framework of analysis. A toolbox with conceptual tools for supporting ontological analysis, for supporting us to understand the nature of the phenomena that we are representing in one of those ontologies with lowercase o. So just to very briefly illustrate this, instead of looking at these elements here in this fictitious modeling language and having these things just as types or unary predicates, we could make justice to the different distinctions among types of types, so that we have a kind of things here, which is to be a person, something that all of us are necessarily. We have certain types that we instantiate contingently, like, for example, now I'm a living person, but I can cease, I will eventually cease to be a living person. Types that are both contingent and relationally dependent. So in order for someone to be a donor, this person, this instance of person has to be involved in at least one transplant. And here we have an example of an entity that is existentially dependent on other things, right? That can only exist if other things exist. So this notion of a transplant. So for a transplant to exist, a surgeon and a donor and a donee, at least one of each of these instance of each of these types must exist. we still can ponder if by transplant we mean an event or we mean a kind of agreement on what can be done and what should be done in a transplant. So here, again, two different types of ontological categories, both of which are existentially dependent types of entities. The difference being that a transplant as this bundle of commitments and claims is something which can change in time in a way that it's similar to how a person can change in time, while a transplant as an event is locked, is immutable, cannot change in any possible way. So, before I move to the next slide, here we are also exemplifying with this fictitious language, a kind of language whose modeling primitives actually do justice to these ontological distinctions. So a language that would code in its concrete syntax these different distinctions, and that would include in its grammar constraints regulating how these different modeling notions and modeling primitives can be put together. And these constraints, these grammatical constraints, would reflect the axiomatization of this underlying ontology, this tiny ontology, again, making a distinctions among types of types and types of entities which are independent or dependent. So a very, very quick exercise on formal ontology here. Here, ontologists can, so that these distinctions that I was talking about between kinds of things and phases and roles played by things and events and these bundles of properties, which are called here relators, they all belong to this domain-independent level. And an artifact that represents those domain-independent notions is what is called the foundation ontology. Foundation ontologies can be used to build what is called a core ontology, so an ontology that is built relying on the support of this foundation ontology, but which on the other hand can serve as support for building ontologies cross-cutting several domains. So here we're going to see one particular foundation ontology, the unified foundation ontology, one project which has been going on for almost 20 years now, in which we have been developing a number of micro theories to all these different notions which are needed in conceptual modeling. Like, for example, typologies of types, taxonomic structures, theories of relations, theories of parthood, theories of events, and so on, and many other of these micro theories. UFO has been used to develop core ontologies in many different domains. Two which are very relevant for us here today is this core ontology of services called UFOS, and the core ontology of legal relations, which is UFOL. And for example, this core ontology of service can be used to support the development of ontologies in particular domains like healthcare services or telecommunication services and so on. And again, these ontologies can serve as a support for the design of modeling languages. For example, this UFO ontology has been used to design, systematically design a version, an ontologically well-founded version of UML called OntoUML. And we're going to see here today two of these ontologies, actually, three of these ontologies, the UFOS and UFOL and the service contract ontology, being used for redesign this Archimate international standard. So let's take a look at very briefly to this theory of relations. Relations in conceptual modeling, traditionally, they are basically equated with a non-unary predicate from a formal point of view, right? So if they are sets of tuples, sets of pairs in the case of binary relations, or n tuples in the case of relations with higher arity. This representation, and then you have this what are called cardinality constraints regulating the population, the possible, the admissible combinations in the populations of tuples in different points in time for those relations. This traditional notation works well for representing certain relations, but not all relations. And that's why then it's important for us to recognize that from an ontological point of view, like not all types are the same, not all relations are the same. So here is a tiny typology of relations, distinguishing, for example, what are called primitive or internal relations, like existential dependence. Like, for example, if my headache is existentially dependent on me, in the sense that it can only exist if I exist, the truth maker of this relation is the headache itself. The sheer existence of the headache makes true that this headache is inheres in me, on me. Let's contrast this with a relation like I'm taller than Christine, for example. If it is true that I'm taller than Christine, what makes this relationship true are our individual intrinsic heights, right? So the relation itself is not establishes no connections between the two of us, and is reducible to intrinsic properties of the relata. I'm taller than Christine if my height is greater than her height. Now let's contrast this with relations like being married to, or working at, or being or studying at, or being treated in, and so on. These relations are not reducible to intrinsic properties of the relata at all. So if John is married to Mary, for this relation to be true, the thing that is the truth maker of this relation is one of those existentially dependent entities that we just saw. It's the marriage connecting John and Mary. And if I work for the free universal boson, it's because there is something, a social object, again, a bundle of commitments and claims and other interesting things that has its own, that it's a full-fledged entity with its own properties, which can change in time and so on, and that being existentially dependent on both of us binds the two of us. And for these relations, the so-called material relations, which are the most common relations in conceptual modeling, this notation is very weak because it obscures many aspects of the domain itself. For example, dynamic aspects, like that some of these entities, the marriage can change in time from partial separation of assets to full separation of assets, that this material content of the relation can have their own taxonomic structure, that there are properties of this truth maker itself, this material content. It obscures the different roles that these entities play in the scope of these relations and so on. So we propose, so the reflection in the language, in the modeling language of this distinction is that for material relations, we need to explicitly represent these entities as first-class citizens. They are reified and included in the domain, so to speak. So here we have the treatment, which is the truth maker of the treated in relation, and we have this kind of existential dependence relations connecting the treatment and the relata. We can then make explicit the different roles played by this relata in the scope of this relation, this relator. We can make specialize this relator type, including different types of subtypes here, like the treatment, the inpatient treatment and the outpatient treatment. These different subtypes can also be dynamic, like a treatment can be active or suspended. We can connect these subtypes to different events, and we can look inside these relators to see what they are made of. And they are, in the case of social and legal domains, they are made of things like commitments and claims and a number of other interesting things that Christine will tell us. This relation on here on top, the original binary link connecting a person and hospital here, is completely derived from this entity. And there is something here which would also be obscured by that original notation, which is
so the goal is just to react and be ruthlessly honest and whatever else. And and her directions are very specific too.
Sorry,
Would
I
you
think
like-
someone.
I think
Someone has
we're
the
picking
mic
up
on.
some back. Michael, I think you were unmuted.
Don't like.
Okay, I think,
Shall I continue?
yes, please.
Okay, so in the original notation, we have an ambiguity on the meaning of these cardinality constraints because they collapse what are called single tuple and multiple tuple cardinality constraints. So when you say a person is treated by zero to many hospitals or in zero to many hospitals, and a hospital treats zero to many people, we don't know how many people can be treated in one single treatment and how many healthcare providers can be involved in the same treatment. So here we can see that by explicitly representing this material core of that material relation, we can eliminate this ambiguity by explicitly connecting that entity, the relator, and the relata. So now we're going to see, and I will, this is another example, sorry, in which we have a service agreement. And a service agreement, which is the result of an event of service negotiation, connects a service provider and a service customer. And it's, again, a bundle of these existentially dependent entities, like their mutual commitments and claims. So there is a pattern here, which can be, it's directly derived from this theory and which can be applied in many instances and in many cases. So now I hand over to Christine, who will tell us about how this theory has been used to develop this core ontology of legal relations.
Thank you, Professor Guzzardi. Thank you also, Dr. Fogel, for this opportunity. Well, when we talk about legal relations, we understand that our lives is completely the law permeates our social lives. Wherever we go, we have the law there. So if you download one app or if you go to the restaurant, we build these legal relations. But sometimes we don't realize these legal relations because it's like air, right? You cannot see, but it's there. So for us, legal relations in the perspective of ontology, we understand that is a relevant concept, and we started to build the UFOL under this perspective, under the relational perspective. And if you see the literature of legal ontologies, we will see several ontologies built under other perspective. For example, legal norms, or also when they use deontic logic just to put as a relevant perspective prohibition or duties and also permissions. So we went to another how can I say, we use another approach and also another perspective to build UFOL. So in the next slide, we will see that we use two aspects to build UFOL. The first one was use one foundation ontology to build a good ontology. As Professor Guzzardi told before, we have to pay attention, because if we don't use one foundational ontology, we have the risk to build one bad ontology. And then if you build a language above this or use this ontology, you have problems, problems of consistency or completude and another aspect. So to build UFOL, we use UFO, And here we see UFOA is the first layer. It's an ontology of endurance, and you can see entities like, categories like substantials, individuals in this ontology. We have also UFOC, an ontology of social entities. And also we use some categories from UFOB, an ontology of perdurance, but we don't put here, it's just 2 or 3 categories. So, but the main aspect of UFOA. So also UFOS, an ontology of surfaces, was based on UFOC. And we combine UFOS and UFOL to build a surface contract ontology. So we can see in the next slide the second aspect of UFOL. So the first one was apply or base our ontology on a foundation ontology. And then the second one was use or apply one legal theory. And we started to investigate some legal theories. We know that in the literature we have several theories. So, but in our perspective, we were looking for legal theory with this theory of relations, a consistent legal of relations. And we found a three-dimensional theory proposed by Michael Reale, a Brazilian jurist. Also a Loophole theories of fundamental legal concepts. And then we also investigated Alexis' theory of constitutional rights. And here we can see a set of legal concepts that we find in Loophole's theory. Loophole proposed one theory of legal positions. So we have 8 legal positions: claim, duty, no right, privilege, power, subjection, disability, and immunity. And also Alexis used this theory, the Loophole theory, to extend this set of legal positions. So in Alexis, we can see the term right, the term permission, and also he put the negation of the object of the legal relation. So when we see in the Alexis theory the set of legal positions, we will see 14 legal positions, because for each legal position he also put the negation of the negation of the object. So, for example, if you say right to an action, in Alexis we have also right to an omission. If you have a duty, we have a duty to an action, and also a duty to omit. So, and he did this, but he didn't apply the negation for the legal positions arise from norms of power. So, and we proposed this with Dr. Lima in one paper published in this year, that we talk about the negation of object in a legal position, power, and also liabilities and disabilities and so on. So here we see that right has this association, correlation with duty. No rights correlates permissions. And the next slide we will see also power correlates subjection, disability correlates immunity. And also we can see that in Alexei that he proposed a new definition for liberty, because in Hofeld, liberty is just a privilege to do something, a permission to do something. In Alexei, he proposed also two kinds of liberty: unprotected liberty and protected liberty. So we use all these legal positions in Alexei to build UFOL. So in the next slide, we will see just one part of the taxonomy of legal relators in UFOL. So here I will just describe some parts of UFOL. Here is just one fragment of UFOL. And we see on the top, we see UFO-A. We have a substantial intrinsic moment in relator. So substantials are entities that exist on their own, for their own. Intrinsic moments are the aspects that can be, for example, the Guisard's headache is one example of intrinsic moment. And also we have the relators, that we have this relational nature, and we are interested in this category. So in UFO-C, it's another layer that specializes UFO-A. We have agents, specialized substantials, social moments inherent in agents, and it's a specialization of intrinsic moment. And also we have social relators as a composition of social moments. And social relators specialize relator. So in UFOL, we put one ontological commitment that law domain or law universe is one specialization of social reality, a social representation, a social domain. And this is the first ontological commitment. We know that there are jurists that don't agree with this view, with this perspective, but we understand that we can specialize the most of specialized legal relations from social relations. So here we have one legal relator, specialized social relator. We have legal relator as a component, a composition of legal moments. And we have also all the legal positions described in Hofeld and also in Alexei, categorized as legal moments. So we have right, duty, permission, no rights, power, subjection, immunity, disability. All this we can see in the Hofeld's theory. And in another part, we can say a specialization of right, for example, a right to an action, right to an omission, duty to act, duty to omission. This part is the extension that Alexei proposed in his theory of constitutional rights. So also we classify legal relators as simple legal relators and also complex legal relators. So we have right to duty relators, permission no right relators, power subjection relators, immunity disability relators, and also the pairs of legal moments. So in one right duty relator, we have a pair right duty, and one right correlates to another one duty. So it's one right correlates to one duty. Also, we have in the complex legal relator, a liberty relator, one type called liberty relator, that is a composition of two or more simple legal relators. So we have permission no right relator. And if we have, for example, an unprotected liberty, we will have a permission no right relator in case permission to act and no right to an omission. And also the conjunction between the permission to an omission, to omit. So we have these kinds of legal relators in UFOL. Of course, we have also other categories in UFOL. We can see also in our thesis, in my thesis, sorry. And also we can see in the ontology of contracts. So here, for example, we have on the top, we have a fragment of ontology of surfaces. We have UFOS. We have some roles here, like hired service provider, service customer, and we have a related service agreement. We have UFOL below, and in the middle we have the ontology of contracts that we called service contract ontology. And in this ontology, in service contract ontology, we have the relator legal service agreement as a specialization of service agreement. And all the moments, all the legal moments that we can see in SCO, it's a specialization of legal moments from UFOL. And we just divided it in legal entitlement and legal birth and lack. Okay, so we have also in our work in UFOL a catalog of legal relation patterns, and here's just two examples. So we have a power subjection legal relation pattern in this. In this example, so the relator termination with previous notice by customer, it's one legal relator composed of power and subjection. And also we have another pattern, a pattern disability immunity, composed by immunity and disability. So all these patterns, the 8 patterns, we can also find in my thesis in the chapter 6. If you, my thesis was written in Portuguese, but if you send me an email, I can send you the chapter in English. And also we did one experiment, a study, empirical study, used the Amazon Web Service agreements, and we had some interesting results because we investigated the quality of the UFOL models, the diagrams, and we in two perspectives, in two aspects. The first one was clarity of these diagrams, and also the correctness. So we saw that in case, for example, the clarity, in comparison of textual representation, for example, textual representation had about 46% of the clarity in this sense of clarity, and in UFOL diagrams had about 70%. So we saw that diagrams can give some this aspect, the clarity for textual, for contracts in a general aspects. So I will now the parts of contract modeling Professor Almeida will talk about, and he talked about the Archimate, and also one contribution that we did with this topic. So Professor Almeida, the stage is yours.
Thanks, Christina. So Giancarlo, told us that simple theory of relations that reify those relationships into relators can give us the merological structure of those relators, can give us taxonomies of relators. So what Christina showed us is that you can build an ontology for these legal relations by using this reification strategy. So we have in UFL this taxonomy of the various kinds of legal relations that can be established with their parts and the roles that agents can play in these legal relations. So by using that, you can take that ontology as a reference ontology and then design or redesign languages whose purpose is to represent the reality that you've just theorized about, right? So we did that with Archimate. Archimate is standard of the Open Group for enterprise modeling. It covers many aspects of enterprise architecture. And one of the aspects that's very underdeveloped in Archimate is the notion of a contract. So we'll see in the diagrams in Archimate that there is a specific, next slide please, that there is a specific element to represent a contract, but there's nothing further beyond this. So services can be given contracts and then they are simply boxes with no further structure. So here, for example, we have this contract between a particular customer and a particular service provider for a certain service, and there's nothing more in Archimate than this. So as a language that connects to business processes and to many other aspects of the enterprise, it would be important to consider also the legal relationships that enterprise enter into and that customers of enterprises, service customers enter into. So what we did, and in the next slide, you see, we added to the language contract elements that correspond to those legal position types that exist in UFL. So here, what you see is the addition of specialized contract elements in the language. In this case here, for example, a duty not. So every person playing the cable TV customer role that conforms to this terms and conditions will have that legal position. So it's a way to represent visually those contracts and incorporate it into the enterprise language that has several other aspects of the enterprise by detailing, but not formally specializing. Not formally representing in details all the aspects of those legal positions. Next slide, you see other kinds of legal positions that can be represented, such as powers here. So here the cable TV customer has the power to require reduction of prices in case of non-conformance to the service. There are also duty nots assigned to different parties. The next slide, you see that we have established representations based on the traffic signs to those legal positions in the theory. This is a hard task because of the difference in the traffic signs in the various countries. So we had to take some stance here. So we have these symbols that are superimposed into the contract elements in Archimate to represent those two parts of the legal relations that are now reified. And also the same for the positions involving power conferring aspects such as power and subjection and disability and immunity. And these together, next slide, Jean, you see that they can be used in combination with the behavioral positions. So here, for example, violations in prohibitions or duty nots, or violations in duties, or can trigger liberties or other positions that can be then exercised by the party. So here we have the legal. So we did a study with the Amazon Web Services, and it's reported in this paper with the supplementary material that we have examined the documents as Christina mentioned, and the same documents that were used in this empirical study, we also represented using the language extension to Archimate. Then the aspect that differs also this approach from others is the representation of these power conferring norms, and in this case here we see an immunity. Also an immunity related to a right, so that that Amazon has. So all these kinds of things can be traced back to the text in the Amazon description, but gives us a visual representation of all these aspects. Next. So we've just shown two simple applications of this reification. One of them is to capture these legal relationships in OntoML models, which can be used to design systems later on, information systems, and also giving us a catalog of patterns on how to represent all these taxonomy of legal relations, and also this redesign of a small fragment of Archimate to incorporate these aspects that are out there. Most approaches, and this was already a question in the chat by Eric, they, instead of capturing legal relationships, they focus on the obligations, absolute obligations, not directed obligations. So in terms of contracts, this representation, this legal representation is very well suited. And many approaches also just take the behavior norms instead of addressing also the power norms. And these were both incorporated in our work. We are also planning some future work on these behavioral aspects, because now, since we have these relationships that are reified as endurance, they can change qualitatively in time, they can change phases, they can have their own qualities as well, so they can themselves change. And this is an aspect that can provide us changes in obligation, and discuss some important issues in the dynamics of legal aspects. There's an important question by Giovanni Sileno in the chat here, which relates to these levels of types and instances. So when we're talking here about there being some kind of legal relator, we can also talk about the legal relator type. So in the foundation ontology, we already have this distinction between higher order types and first order types. So there are these two things in the ontology. And in the next slide, you see the paper where we explore this service contract modeling and enterprise architecture, where we do not only have this taxonomy of first order relationships, the types whose instances are those relationships that hold between specific parties, but also the types of relationships whose instances are types themselves. So there are these two levels in all these things that are possible because of the higher level ontology that gives us all these reification of legal relationships, but also of legal relationships types. So you can find out more. There are papers here in the UFOL page, just Google for UFOL, and you find these two specific applications that we've mentioned here today, one of them in the conceptual modeling of legal relations in ER conference, and the other in the Information Systems Journal.
Great, Shaw. Thank you. Folks, do you have any questions? You already answered Giovanni's question, right? On the so this is you have always sort of, you said a 2 decades long stretching research effort, and it's ongoing. And what are some of the are some examples for how it's used in industry already?
Yes, so maybe I should answer that. So we have it's being used to analyze and redesign many standards, many conceptual modeling languages as well in different sectors, enterprise languages, in many different domains. Also, it has influenced some international standards like the Archimate standard, for example, Now, next year, we're actually working on the proposal of a submission to be considered at the ISO to become a standard itself. So there is let's say a library of standards which are related to foundational ontologies there. So a call for proposals, and we are working on a proposal. UFO, through this, the manifested in this conceptual modeling language called OntoUML, has also been used in many different industries by many different governments. One interesting application was actually by the DoD, one engineering department there that started using the language very early, around 2006, if I'm not mistaken, and published back then a kind of booklet of explaining its use there, which was related to this problem of having to deal with semantic interoperability with technology independence, right? So that the models can be implemented using many different types of technology, but still having to have very precise models.
Okay. Giovanni is asking, in terms of reasoning methods, what are the tools and solvers you utilize with UFOL specifications? What type of queries are you able to support, which not?
João, do you want to take this one?
Okay, so there are different parts of the specification of UFO. So UFO itself, it's specified in first order logics. Well, we used in the latest paper some modal aspects that we need of alephic modal logics, but in the formalization that we've made, everything is, and that's fully available in the TP syntax. We've just used first order logics, but that's to formalize the UFO foundation ontology itself. And we've also built another version called GUFO, which is all in ALDL. So you can also use semantic web technologies for any of these queries. So that the answer is we have both of these things, and now we are connecting these two things because in the ISO standard that we are going to submit UFO for, you need to establish the relation between the first order formalization and the LDL formalization.
Great. So Mark's asking, is there a nested UFO ontology that would give a three-dimensional view of the captured legal relationships within the hierarchy of the legal ecosystem in which it exists?
So Mark, what is this? What do you mean by three-dimensional view? You mean really a visualization, let's say, of this? I mean, a visual representation.
Yeah, it was partly just a sort of thinking around the visualization, but also in the way that you can see it really existing in the legal ecosystem in which you would apply it, so that you could actually understand the weights, if you will, upon which that ontology would play out.
No, we don't have a tool like that. With Archimate, what you have is these snapshots of the visualization, which can represent both at the type level, these types of legal relationships that exist. So let's say those that exist at the levels of contract templates, those that exist at specific contracts that are not yet with the specific parties that are bound, and contracts that are specifically bound, which means we have patterns to represent those situations. And the tools, they allow you to draw these diagrams, right? But nothing, let's say, in terms of the evolution in time or some other kind of, if you're talking 3D in this sense, not yet.
Maybe we can also say that when we talk about legal relators, we talk about endurance, not perdurance. So maybe it's when he talk about the three-dimensional view, maybe he put also the dynamic, the perdurantism perspective, right?
Yeah, the foundations are there for you to do this, right? But you're asking in terms of tools for visualization, and then Roland, I
maybe-
also see here if we have time, Eric's asking about.
Yeah, that's a good.
question.
Let's go to Eric's question, and then maybe Peter's, and then we have to wrap up. We're already at the end of our time. But Eric's asking, like, how much time
Yes.
does it take to formalize complex legislation? For instance, 370 pages of complex.
Yeah, yeah, absolutely. That's a question for anyone doing work on specification or and here we're not proposing any kind of a detailed logic-based representation of the content of all of the legal positions, right? So that's actually a question for those that are doing that. We could annotate those, for example, those complex pages of legislation, but we're not in the business of spelling out the detailed content of all the provisions, right? So it's a kind of a I agree. This is a fundamental challenge that anybody will have to face for the scalability.
Okay, so is that what you're saying? Because that's one of the questions. Like, you're saying this is sort of a base ontology, foundational ontology, but then it is sort of the role, depending on which area you're operating in, to create a specific domain ontology to, like, to have a specific model. Is that what you're saying?
Yes, but at the same time, you also you can go as deep as you want. So if you don't want to open up the contents of specific duties, for example, right? You don't want to say specifically what happens for that particular provision, but there's a duty there, right? So you can at least query for all the duties in the contract, and you get textual descriptions of this. Maybe you don't get formally interpretable of everything, because of the very reason that Eric is putting forward here, because there's no one doing all this formalization, right? So you can choose the level of formalization, but you need to start with a basis that gives you the basic concepts for formalization, because formalization in itself will not give you these taxonomies that you can plug in those domain specific notions of specific legislation in a general framework provided by a legal core ontology like you as well.
Okay, and then final question to Peter: does the system have any code generation capabilities to ensure the software implementations will maintain correct semantics?
Jean, maybe you can tell us a little bit about the OntoML tooling for this.
Yeah, we have several different mappings from OntoML to several different languages. So the goal there is to focus on the conceptual modeling phase, trying to maximize quality requirements like expressivity and clarity, and making these distinctions explicit. And then we have several different mappings addressing different design problems. So we can generate a database. There are people in the community that have worked on mappings to JavaScript and Smalltalk and Modal Prolog. But even, I would consider a language like OWL a type of implementation language. So it's like an object-oriented Prolog. So there are all these different mappings. Also to Alloy, which is this language, the simulation language proposed by Daniel Jackson from MIT, that we have been using for a while to validate these models, to play this, breathe fire into these equations here and see the models come to life. Yes, so there are all these different mappings, most of which are already implemented in the newest version of the tool, of the OntoML supporting tool. Got it.
Well, thank you so much. So this has been really fascinating, and thank you for sharing your work in the space. And there's so much more to discuss. It'd be great if you could put your email addresses into the chat so folks could reach out directly to you to continue the conversations. But yeah, let me thank you on behalf of everyone, and sort of give you a round of applause. And it was wonderful to have you as our last session this year. And I thank everyone in the group for participating in our CodeX group meetings and for sharing your insights and perspectives. on the many different discussions we've had this year. I think it was a challenging year still. But our regular group meetings have certainly been, sort of a ray of light, I think, in a challenging year, and it's always been great to bring the group together, and it helps us at Stanford understand, what folks out there are working on, and it's just great to bring you folks together. So with that, I wanted to thank you again, everyone. Thank you to our speakers, everyone who spoke at the group meeting this year. And I hope you all have a wonderful and relaxing and peaceful holiday season. And I look forward to reconnecting in 2022.
Thank you.
Take care.
Thank you, Susan.
So
Thank
I
you.
can make
Thank you, guys.
I can make a quick announcement, given the NUPA's question. Next year, we continue virtually, and our next CodeX group meeting is scheduled for January 13th. So
Thank you, Susan.
watch your email.
Thank you so
And,
much.
yeah, sure. And future law registration opens next month in January. So check your inboxes.
All right, guys. Take care. Stay safe.